Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we'll publish the events that we stored in the outbox table to our event bus, which is based on Apache Kafka, as we introduced in the past episode. Just a heads up, the solution I came up with is over-engineered a lot, so I probably don't recommend to go with the exact same solution, but hopefully some of the ideas are useful. So I'll just roll with it, even though I don't think I would recommend following this exact approach. So in this episode, the main topics will be defining an interface for event publishing. So it's generic and abstracts the application from the fact that it's using Apache Kafka. So if we would want to use a different system, for instance, if we are using some Azure or AWS and we want to use the messaging systems that they have instead of using Kafka, we could do that. Then we'll implement an event publisher of this interface using Kafka. Before bringing it all together, we'll see how to run Apache Kafka locally. It's not like a tutorial. I just followed some things on the interwebs and from Confluent, which is the main maintainer of Kafka. So hopefully it can help if you want to play with it locally as well. As usual, if the videos are being useful, consider dropping a like, sharing and leaving feedback. All important to help the channel. And for more stuff, all the videos have an accompanying blog post in my blog. You can also ping me on Twitter, or if you want to contact me in some other way, the blog and my personal website have some additional means of contact. So with this done, let's go. Before looking at the code though, let's just see this diagram that I introduced some episodes ago. So this is the whole picture of the publishing event stuff. And the topic of this episode is this part right here that you see in blue. So we already did all of this part. So we are registering the events to the outbox table. And we created the outbox publisher. In fact, we have two of them. Like I mentioned, you probably should have only one to guarantee ordering. So maybe I'll fix it in the future. But if I don't, remember, if the order is relevant, maybe going with just one type of publisher, namely the one that reads the events in sequence from the outbox, is the ideal way. But I won't touch that right now. So we'll just implement the part that the outbox publisher actually calls the event bus. So we'll implement something in between to do this. So just put the topics here to remember, and let's begin. So to implement the Kafka client, we'll use a NuGet package available that is Confluent.NET client for Apache Kafka. As I mentioned, Confluent is the main company that's handling Kafka. So they created a .NET client and we can use it. And we basically will create a simple interface to abstract this and then implement a thin wrapper around this, which is maybe you can call it an adapter over this client, just for the application to not be dependent directly on this package end in Kafka. So to the code, I created this library here in a shared package. Eventually this should be a NuGet package, but right now it's just a package somewhere in the file system that the other application will be able to reference. And over here created a bunch of stuff, and we'll start by looking at the Ievent Publisher, which, as you'll see, is a rather simple interface. Let me minimize this. Just has a couple of methods, and could be only one, but I created two. So we can publish one event or publish two events with the usual task-based async stuff and the cancellation token. And the Ievent Publisher is bound to a type of event, so it's strongly typed. So when we inject, we can say the kind of event that we will want to publish. Not the exact kind of event, but the base event for a given topic. But we'll see this in the implementation in a minute. So the interface is pretty simple because it's just a way to decouple our application from the Kafka implementation. But now let's see the Kafka implementation, which is over here. I created other things, some serialization related things, dependency injection helpers. We can take a look in a few minutes, and Kafka implementation. Over here, again, some other helpers and the important thing, Kafka Event Publisher. So Kafka Event Publisher implements that interface with the event. It has an added difference, which is the type of key, because as we talked about in the past episode, Kafka can use the key or some other function to choose to which partition to write the event or the record. So we are saying here that we have a specific type of key that we'll use to route the event. Then in the constructor, we get a bunch of things. For starters, we get the topic, and like I mentioned, because the Ievent Publisher is typed, we can think of that this type, which will be the base type of events that will go to one topic. So when building an instance of the Kafka Event Publisher, because it's for a specific topic or specific type per topic, we can provide immediately the topic that this publisher will publish to. Then I have some settings, which if we take a look in there, right now only has the servers to connect, not much. And then we get some other stuff. We get an iSerializer, and this is an interface from Confluent, implementation of the client, to serialize the key, and a nice serializer for the event. Because we can put whatever in Kafka, we provide a serializer that writes there the bytes in the right way. And also we got a function that gets an event and returns a key. Why is that? Like I mentioned, we will use the key to choose the partition. But because this event publisher is generic, we don't have a way to know what is the key. So because we have a bunch of properties, how will you know what is the key to pass on? So we use a func. So then we pass the event to the func, and the func will give us the key. So continuing on, we store some stuff. Then we create a config. Again, this is an internal class to the package from Confluent, and we set the servers and the type of partitioning. In this case, we're saying consistent, which if we go to the docs somewhere, we'll say or not very useful, but basically it means that all the events with the same key will go to the same partition, and it will be a distribution and stuff like that. There are a lot more properties here, and to use this in production, probably we should take a look at more of them. I guess they have some defaults, which probably are good enough, but just in case, it's a good idea to take a look at it. But I won't go into that detail. Then, a producer builder. So producer is the name that this package calls the publisher, producer, whatever. And create a producer builder, and then we can set thing. So we create a new one passing the config we had, and then we pass in the value serializer. Then if we have a key serializer, if it's not null, because we could publish it without key if we don't want to send to specific partitions, we can just not put keys and it will go random. Or better yet, if we want to go random, we should put this, I think. But just in case, I put over here. If we don't want to put a key serializer, we don't. But of course, as you'll see by these inconsistencies, this is not production ready. So just take that into consideration. And then at the end, we store in the producer the result of the producer builder.build. And this is the reason why we have this iDisposable here, because in the end, we dispose of the producer. Then publish async. It's not a lot, so we call the producer produce async. We say what the topic is that we want to publish to, the key, and to get the key we are using the key provider. And now I'm noticing that probably I should have checked if the key is null, if the key provider is null. So this will throw an exception if we don't provide a key provider. A value and a timestamp. And you notice that we are just putting the key and the event directly. We're not serializing, because over here we set the serializer, so the value serializer and the key. So the library itself will take care of serializing things. And that's mostly it. We created the message, pass the topic, and produce. That's it. For the publish async, that gets a collection of events. It's basically a for each doing the same as above. If there is some batching like API, it would be interesting, but I haven't found a way to do it, so maybe it exists, maybe not. But that would be interesting because it would improve throughput. So it's a thing that probably would be interesting to take a look at. But for now, as I didn't find it an easy way to do it, just for each produce. And that's it. This is the publisher, which isn't very complex because we are using a library. The library itself is complex in this case, but our implementation is not, because we are just using it. Now for other bits. Let me close this. So the next thing is the topic distributor. This is the part that's over-engineered, so I won't go into much detail, but I just want to mention it because otherwise, if you look at the code, you don't really understand what's going on. So let me open this and this one. In the Kafka Event Publisher, remember we got the type of the event. And this is tied to the topic, because type of event, topic. So how do we do this tie? So before, let me go up here in the auth. I created a library with the events. So basically I created a base event, which is base auth event, which will be the base for all events published from the auth service. As an ID, as an occur that. That's all. Then what I did was creating another base event, but in this case a base user event, which inherits from that one and adds a user ID, because all user related events should have a user ID. Why is that? So this base user event will be tied to a topic. So we'll create a topic in Kafka, which will be user account events, for instance. And all events that inherit from this one will go to the same topic. So in this Kafka Event Publisher, what will happen is it will have a key of type string. Here, an ID of type string. And the T event will be of type base user event, because this is the one that is tied to the topic. So this would be good enough, and in where we want to publish the events, we could inject an Ievent Publisher of string base user event. But what's the problem here? If you remember from the past episode, in the application somewhere I put the stuff, infrastructure, events, so fallback publisher. In here in the publisher, we just go to the database and we get the messages, regardless of what kind of message, and then we try to send them. So what's the problem here? Because right here it will get all the messages that are in the database. Right now all will be of base user event, because we only are implementing these kinds of events. But if we would have more kinds of events, so instead of just base user event, we would have, I don't know what we could put here, another kind of event that is related to auth, but not specifically to your user, maybe, for instance. And in this case, it wouldn't be it would be our goal to put it in a different topic. So it would not be a base user event, would be base stuff event, inherit from this one. And in that, if we did that way, this outbox publisher would need to get multiple types of Ievent publishers with different generic parameters in order to pass things. So instead of putting that difficult logic in here, I created that topic distributor, which will be basically like an adapter. So in this case, the service root event will be the base auth event. And internally, with dictionaries and some reflection trickery, what I do is every event that's passed in, it's aggregated, is checked what is its type, and then we get the correct Ievent publisher. So right here in this part, we get the correct publisher from the service provider, so we can publish it. But to achieve that, I did a bunch of trickery, reflection and stuff like that I won't show you. You can see the code, and if you have any questions, ask away. But I think it's over-engineered and not really needed. There are probably other ways to achieve it, but what I did was basically put all the complexity in one class and simplify all the rest. Don't know if it was the best approach, probably not because of the over-engineer here, but I felt like it. But that's why I'm saying maybe don't go with this approach. So this is what the topic distributor will do. So inside it will map all the types of events that we'll configure. So in the constructor we get the service provider, so we can get things, and we get the iRead-only collection of base event types. So we'll get, for instance, in this case, a base user event. And then over here I have some methods to create the mappings between events and base events, but again, not going to show you, just wanted to mention why this topic distributor exists. Now, before tying it all together in dependency injection and so on, maybe we'll take a look at getting Kafka to run so we can actually use this. So let's go over here in this folder where I have some start scripts. We start over here. So this is where I put the dependencies in a Docker Compose file, so we can start things before starting the application. So Postgres was already here, but then we have a bunch more stuff, which is to start Kafka. So I don't know all of this. I had never used Kafka before. So I wanted to run Kafka locally, and finding on the interwebs, what I found was this repository from Confluent again, which has some recipes for Docker Compose files to create a Kafka cluster locally. And there's a bunch of them. So CP all-in-one cloud, CP all-in-one community, CP all-in-one, stuff like that. So I just went here, took a look, got just what I wanted because there are a bunch of services running here and I just wanted the minimum, and created a Docker Compose out of that. And this is the result. So for starters, we have Zookeeper. As I mentioned, I think in the past episode, it's just a coordination tool for distributed systems, which is used with Kafka, and it's required right now. I think they are planning to stop requiring it and put everything in Kafka, but right now it's needed, so we set up Zookeeper. Then we have the broker, which is Kafka itself, Kafka broker, all the stuff. Again, I copied most of these things, just removed some things that didn't seem like needed and other stuff that I'm not sure. I just whatever. Just want it run locally, because if I wanted to use this in production, I would probably not configure this. Probably someone from ops would do it, or we would just use some managed instance from a cloud provider, stuff like that. So, but we have the broker, which is Kafka itself, and this would be enough, Zookeeper and broker. But because we don't have a consumer yet, and we want to see that the events are actually being published, I also put here the control center. That is like a UI that we can use to see what's going on in the cluster. And one of the things that it allows us is to see the topics that are in there, so we can see the messages. And it's helpful right now where we don't have everything working yet. And at the end, I left a note here to point to where I grabbed the information about Kafka to put in the Docker Compose file. So with this, we can now run this. So start dependencies. I forgot to create Docker. Just a minute. Okay, Docker is up. Starting things. Okay, we have Zookeeper, broker, control center, and Postgres all running, so we can start the application. Just before that, let's take a look at the final bits. So going back here to the code, I've already shown the Outbox publisher over here where it's publishing messages, so not much going on, just grab the message from the database, map them to the event buzz version, because I created a couple classes, one for the events that are stored in the database and other for the events that are outside. And then over here all the stuff, and the other difference is it's the event publisher is being injected, and like we talked, is a base auth event. So this means that it will use a topic distributor, which inside will send to the actual Kafka event publishers correctly. But yeah, over engineer much. More stuff. So this is the usage, which is simple. That's the goal. Moved the complexity out of the usage. But then we have some complexity in other places. For instance, in dependency injection. So in the event extensions. So until here was already present. This is the new stuff. So I'm setting a topic distributor and saying that it will be a topic distributor of base auth event. And the base events for each topic are the base user event in this case, and could have more. And inside, it's just calling the constructor in the way I mentioned earlier. So this is just a helper for that. And then we have a add Kafka topic publisher, which again will just invoke the constructor of the Kafka topic and put it in the iService collection, just a helper. And I hard coded here the name of the topic, so user account events. I'm getting the Kafka settings, which are the general Kafka settings, so the broker will be the same for all topics. Then, if we look at here, this is the serializer for the key. So because this key is just a string, we can use a default serializer that is available from Confluent's package. And then for base user event, we have a JSON event serializer. I can show you this. So as I mentioned, I think I mentioned in the past episode, ideally, because Kafka it's just bytes, we can put whatever. Normally people use or Apache Avro or protobuf to serialize things, because there are binary formats that are more performant. But because this is just a demo, I'm using just JSON. Is more than good enough for the demo, and shows that Kafka, you can just put there whatever you want. So this JSON event serializer uses that interfaces from the NuGet package, so iSerializer and iDeserializer. I'm using Newtonsoft JSON like I did for the database, because I want to be able to have the type information in there so it can serialize correctly instances of classes that inherit from the base topic classes. And then I'm just doing so getting the UTF-8 bytes from the serialization of the object, and the deserialization, the same thing. Because the serializer, what it wants is bytes, so we can put whatever, and that's what we are doing in this case with JSON. So going back over here, and finally we have that key provider. So we are saying that in an event of type base user event, the key will be the user ID. So all events for the same user will go to the same partition, so the order will be guaranteed, and the consumer can do that process in sequence. Now let's start this and see it working, hopefully. I have started the dependencies. One thing you might notice from the code is I am not really taking care in case some of the dependencies are down when I start the application. So that's wrong. We need to take this. Maybe the broker is dead when we start the application. We need to remember that and retry until it's available. I haven't really messed with that yet, but keep in mind that's probably more important than the over-engineered stuff I did in the topic distributor. So we have the application running. So let's go here. For starters, let's go to localhost 9021, I think. Yeah, this is the control center, that other service I showed you in the Docker Compose. And if we go to the cluster, there are topics, but they are probably internal to Kafka. So if I go over here, brokers, we have one broker. And I don't have stuff correctly set up, because this is what interests me. I want to see the topics, and we have no topic yet because we haven't tried to send a message yet. So let's go over here. I think localhost 5005 account. What's missing? HTTPS. Okay. So let's register a new user because the database is empty. So test@test.com, password, register. Okay, so our user is registered, and now we have a topic named user account events with one partition, because I didn't set up anything, so probably we'll only have one partition always. And the partitions, we can see the messages here, and we can go to an offset, and I'll put 0, and we have a message. Looking at the message, we can go over here. So we have the partition 0, offset 0, because it's the first message ever published, the timestamp, create time, headers, key. So this key will be the user ID. So if we look at it, and apparently the control center is intelligent and sees that it's JSON and is able to look at all the things. So this key will be the user ID. So if we look at user ID 8585 stuff, which is the key 8585 stuff. The value type, if we can see that's a user registered event. So looks good. Username test as we put, and value ID, which is an ID I put every time we create a new event. And that's all. So if we go over here and maybe changed it to test1, save, go back to the control center. Now we have two messages. You see the key is the same because it's the user ID. And the event now is a user updated event, as we can see down there. And the rest of this stuff, mostly the same. And if we want to double check that the user ID is actually this one, we can go to the database, do a select. And we have here the user ID 8558 stuff, test. And it seems to be working. If we go back here and set the previous again, now we have another entry which put back the username to test for the same user ID. So we have Kafka stuff working. You can see the offset. So 0, 1, 2, and so on. So our solution is working, over-engineered, but working. Hope it's useful. But again, if you use this stuff, try to simplify. It's maybe a better approach than what I took. Looking at this, yeah, I think talked about everything. As usual, if you have any questions or remarks, feel free to drop some ideas, some comments, and so on. And hope to see you in the next one. See yous!